In PSpice, you can perform Monte Carlo analysis to randomly vary the component values within its set tolerance range to get the circuit response and statistical data. To perform Monte Carlo analysis in this amplifier circuit, first let's define the tolerance for all the resistors and capacitors in the schematic. For this, launch the Assign Global Tolerance dialog. Go to the global list, click on R, and define its postol and negtol values for resistors as 5%. Similarly, click on C and define tolerance for capacitors as 2%. Next, let's set up Monte Carlo analysis in the circuit simulation profile. In this, enable the Monte Carlo option. Here, you can define the number of runs for the analysis, the output variable, use different distributions like uniform Gauss or Gauss user, provide a random seed number, and select how to save the data for the runs. One can also define custom distribution by defining values as deviation and probability pair, with deviation from -1 to +1 in increasing order and probability greater than 0. There is also an option to use Monte Carlo history support to load the parameter values from existing simulations or save the values for current simulations as a Monte Carlo parameter file. You can also define collating function which specifies the operation to be performed on the values of output variable. Further, you can list the model parameter for each run in the output file. Run the simulation. After the simulation finishes, select all sections and launch the Performance Analysis option from Trace menu. For Monte Carlo analysis, this enables plotting the measurement as a histogram. Now, add the trace by selecting the measurement, max, and the output variable, Vout, to plot the max of Vout as a histogram. You can change the number of histogram divisions from Tools, Options, Probe Settings, General tab. Below the histogram, you can see different statistical results like mean, sigma, median, and 3 sigma values. Launch the simulation output file and scroll down to Monte Carlo summary. It lists calculations for mean deviation, sigma, and lists all the runs with values of collating function in decreasing order of deviation from nominal value. Here, at run number 16, the Vout is calculated as 0.9118, which is 2.39 times the sigma value and is higher than the nominal value at frequency of 1.51 kHz. Similarly, all the other values are listed with maximum deviation from nominal values. This is how you perform Monte Carlo analysis in PSpice and analyze its results.